This video will walk you through the proper method of replacing your Bellows-Style canister of tool joint compound on your ditch witch drill. You can tell when it is time to change your canister because as the canister empties, the bellows on the side compress to squeeze out every possible ounce of material. When doing this or any other workaround equipment, you should always wear the appropriate safety protection. To change out the tool joint compound canister, first unhook the rubber latches on both sides of the clear cover. Gently lift the cover straight up to remove it and carefully set the cover aside. Remove the old canister by grasping the sides of the canister and rotating it counterclockwise 1/8 turn. Lift the container off the pump plate and set aside. Be sure to discard the empty container according to your local regulations. In the bottom of the port are sharp metal knives that are used to remove the seals from less viscous products than the tool joint compounds that are used in all ditch witch applications of the bellows system. To avoid injury, never reach into the port. Check for any debris in the port and remove with a non-scarring probe and wipe off the pump plate port to remove any debris and old grease, being careful to wipe it away from the port. There are both non-metallic and copper tool joint compounds available in the Bellows-Style canister. Select the appropriate type of genuine ditch witch tool joint compound for your job, open the box, and lift the canister out of the box, then place it on a work surface to ready the canister for installation. In this system, the port on the top of the pump plate where the canister connects contains 4 notches, and on the neck of the container there are 4 corresponding pins that will be inserted into the notches to secure the canister to the pump. Before you insert the bellows, you need to first fully remove the foil seal from the opening of the new canister. First, unscrew the lid to expose the foil seal. Your canister might have a standard foil seal or a new pull tab seal covering the opening. If you have a standard seal, pierce the seal with a screwdriver and pry it off. Remove any parts of the seal that remain on the canister opening, being careful to keep them from falling into the canister. For the pull tab seal, grasp the tab and pull to remove. If any of the seal breaks off, remove it from the canister. After removing the seal, check that the O-ring on the spout of the canister is not damaged and is seated into the groove on the neck above the pins. There will naturally be some separation of the tool joint compound. You can gently squeeze the canister and pour off the separated material and dispose per local regulations. If there is an excessive amount of separation, contact your local ditch witch dealer with the lot number from the canister or box. When the seal is fully removed and any excess liquid is removed, the canister is ready for installation. Grab the canister by the bottom and move it to the pump on the drill. You can avoid having to prime the system by preventing an air gap from being introduced into the system. Squeeze the canister from the bottom so that 2 inches of compound is exposed out of the top of the spout, and carefully invert the canister and insert the spout into the port in the middle of the pump plate, with the pins on the spout aligned with the notches in the port. The exposed compound will fill the void in the insertion area and force out the air. With the canister properly seated into the notches in the port, rotate clockwise 1/8 turn to lock in place. You should be able to feel it click into place. Replace the canister cover with a gentle rocking motion until it is seated on the pump plate. Hook the rubber latches on either side of the cover to secure it in place. Test the sprayer for proper flow of tool joint compound. In most cases, the pump will remain primed, and you'll be ready to continue drilling. If you follow these simple guidelines, the bellows canister system should work continuously from one canister to the next. But if your system is not functioning to specifications, we have the following troubleshooting and solution tips. If an air gap is introduced above the suction check valve, by removing the bellow and reinstalling it, or if the canister has been used past empty, you will need to prime the system. Priming the system is a simple and quick procedure. Use a flathead screwdriver to rotate the bleed screw at the front of the pump counterclockwise until it stops. Do not force the bleed screw when opening or closing it. Forcing the screw past open or forcing it over tight can damage the system. Attach a grease gun to the priming inlet Zerk on the left side of the pump. To avoid problems with your system, be sure to use genuine ditch witch grease, which this system has been designed for. Add grease until tool joint compound begins to flow from the priming outlet located to the right of the inlet Zerk. You need to pump at least 15 to 20 pumps of a hand-pumped grease gun, or the equivalent of an electric grease gun, to fully purge and prime the system. Do not just pump until product begins being expressed from the bleed port. keep pumping to fully bleed the air from the system. In our example, we replaced a container of copper compound with a non-metallic container, and you can see how much product it takes to fully bleed the system. Always collect all expressed grease and dispose of it according to local regulations. When fully primed, rotate the bleed screw clockwise until snug to close. Trigger the sprayer to verify proper flow of the tool joint compound, and you're ready to continue drilling. It is possible that you might have contamination, like a piece of the foil seal from a canister or other debris, in the suction check valve of the pump. If little or no product is flowing through your system, it is possible that a piece of foil is stuck around the ball of the suction check valve. To check for a blockage, carefully remove the grease out of the pump plate port. Remember that there are sharp knives in the port. Do not ever stick your fingers into the port. Use a plastic or other non-scarring tool to scoop out the grease. If you are unable to locate any obstruction at the top of the valve, you will need to remove the pump plate and disassemble the valve. To take off the plate, remove the 4 screws from the top of the plate and then lift off the entire pump plate. Inside the port will be a spring. Remove the spring and clean the old grease out of the cavity. Being careful of the knives, you can push your plastic tool into the opening in the middle of the top of the pump plate and push out the ball. Clean off the ball and the spring, checking for and clearing any contamination or damage. Replace any worn or damaged parts. Clean and check the O-ring on the neck of the pump plate and clean the ball seat. To reinstall the plate, add fresh grease to the ball seat in the middle of the plate, replace the ball in the seat, and lubricate the O-ring on the neck. Replace the spring in the middle of the check valve, using some grease in the bottom to hold it in place. Carefully invert the pump plate, with the ball held in place with the grease, and reinstall on the pump. Line up the bolt holes and press the pump plate into place. If it does not fully settle, you might need to adjust the location of the ball with your non-scarring tool. Next, prepare the bolts to secure the pump plate by coating the threads with blue 232 Loctite and reinsert them into the holes in the plate. Thread them by hand, then you can use a ratchet drive to tighten them to snug. Adjust a torque wrench to 110 inch-pounds and torque the bolts down. When the bolts are properly tightened, you can replace your canister. Invert it and compress the bellows so that tool joint compound to fill the port with grease as you are inserting it, and then fully prime the system as outlined earlier in this video. It is possible that you might have contamination, like a piece of the foil seal from a canister, stuck in the exhaust check valve of the pump. To check and correct this, you need to disassemble the valve. Use a 7/16 inch wrench to remove the sprayer hose from the fitting that connects it to the pump. Then use a 1 1/4 inch wrench to remove the fitting from the pump. Inside where the fitting connects is the exhaust check valve. There is a ball, a spring, and a ball check disc, held in place by a snap ring. Use a plastic tool or a shop towel to remove the grease and locate the snap ring. Remove the ring using a snap ring tool. Using the plastic pick, remove the disc and the spring, and finally the ball. Clean the ball, the spring, and the ball seat inside the pump to check for and remove any pieces of seal or other contaminants. You should also take the opportunity to clean the pump fitting by using a cotton swab or twisted shop rag to clear the channel of any debris or old grease. When you are ready to reassemble the valve, be sure to align the spring with the chamfer or narrow side of the spring towards the ball. Then place the disc with the convex or outward protruding side facing the spring and ball. Insert the ball into the pump, then insert the spring. You can place some grease in the valve seat to hold the parts in place and use the non-scarring pick to position the spring in line with the ball. Insert the disc and use the pick to press it into place against the spring. Now use the snap ring tool to replace the snap ring and make sure that it is seated into the groove so that it tightly holds the disc, spring, and ball in place. To complete the reassembly, replace the fitting and the sprayer hose. Fully prime the system, as detailed earlier in this video, and test for proper function. If you cannot find any pieces of the seal or other contaminants in the suction or exhaust check valves, but you still suspect a blockage in the line, you can pump hydraulic oil or lightweight oil through the system. Fill the cavity on the pump plate with oil and pump it through the system and out of the nozzle to help flush the pump, hose, and nozzle. After flushing, you will need to fully reprime the system. If these solutions do not correct the issue, we have also seen problems with faulty priming grease zerks, which could allow air to be sucked into the system. Similarly, we have seen contamination from a dirty grease gun tip getting into the Zerk check and not allowing the Zerk ball to seat properly. When the pump retracts, the Zerk may be allowing air in. For this issue, the first solution is prevention. Cap the tip of your grease gun when not in use, and clean and purge the tip prior to priming the system. After that, if you think the Zerk is the issue, replace the priming Zerk and prime the system. Following these simple steps for operation and maintenance will assure worry-free operation of the Bellows-Style Tool Joint Compound system. For more information or to purchase genuine Ditch Witch tool joint compound, contact your local Ditch Witch dealer.